Hey, hello everyone. Welcome back to another episode of the engineering side of data. Talking about developer ergonomics today. And I've got a great guest to help us do that. His name is Joseph Machado. Joseph, thanks for coming on the show, and please introduce yourself.
Yeah, thanks for having me, Bob. It's great to be here. Hi everyone. My name is Joseph Machado. I work as a senior data engineer at LinkedIn. I've been doing data engineering / data science stuff for about 8 years now. Started with MapReduce, then went on to Python scripts, that run manually, and then cron schedule, Airflow, and then EMR, those sort of cloud technology. So I've seen it go from like the start complex stuff to what even more complex stuff we have now. So yeah, that's me.
Excellent. Yeah, I remember we've had a conversation before about some of your MapReduce experience.
Yeah.
I haven't talked to too many people with that background, so that's very interesting. I mean, you definitely were inside the guts of distributed systems of working with data. So I find that very fascinating. Yeah. And by the way, I don't think Joseph mentioned it. If he did, I apologize. But he has a great website called Start Data Engineering. Is that correct?
That is correct. Yes.
Yeah.
So it's a blog mostly about more like practical data stuff. So like how to code the right way, how to design, how to think about design, things of that nature.
Yeah, a lot of great content out there. So check that out. I think there is a link in the show notes for that. I'll make sure that it makes its way in there. So yeah, thanks again for coming on. And let's get right into the topic at hand. Developer ergonomics. Why do we need it?
Yeah, that's a really good question. I think the major kind of reason we need developer ergonomics is to increase velocity. So when I say velocity, is development velocity. Whether you're fixing a bug or deploying a new feature, you typically want to be able to quickly iterate on that. So developer ergonomics, in my mind, the end goal of developer ergonomics is just to go from logic to production quick. And this involves testing and version control as well. Yeah.
Nice. So what are some of the, you kind of listed a high level goal there of speeding up the developer cycle. What are some more of the details behind that, if you don't mind sharing that?
Yeah, sure. So typically, if you think about web development, you have like your application and database, and then you just develop on that. You push a PR, you run some tests, that's it. But when it comes to data, there is a lot more complexity in that you can't really test your data locally sometimes. So thinking about your data systems in such a way that you are speeding up your code writing to code deployment time is the main goal, as I mentioned. So some of the kind of nuances or some of the sub concepts of this are like being able to keep complexity low and keeping the number of data tools minimal. That way you're not dependent on like 3 tools that you can't really test locally, and then now you're blocked because you have to test in production and that might break. So that increases the complexity and increases the development time. And it also is very manual and leads to a lot of like breakages if you're not very, very careful. The other main thing is having CI/CD. Most data teams do not have CI tests. So CI tests could be like just running some tests on staging data and running some static analysis on your code. So having that also prevents a lot of bugs and also like makes you more confident in your code. The other thing is I've seen a lot of data teams focus heavily on documentation. So they say, do this, do that. Instead of having it in a document, it's better to have it as a script when possible. Because if you have it in a documentation, it is prone to manual errors as always. So when a new person onboards or when you're tired for whatever reason, if you follow a document, there is a high chance that you will miss something. And when it comes to data pipelines, if you do not configure something right and a pipeline runs, you might end up generating incorrect data. And then now you'll have to revert the entire data set. So having a little bit of more automation around things that you have documented which could be automated is also a key point here. So yeah, those are the main ones.
Yeah, wholeheartedly agree. And I think most people would agree with that, and especially your points about the CI/CD pipeline and having it as efficient and automatic as possible. One thing I think that people don't think of, and I think what you touched on was very important, was the keeping complexity low. I think that's a very undervalued point in all this, right? I think that as engineers that maybe we chase the shiny a little too much and we like the tools and perhaps we have too many. And perhaps we write too many as well. You know, there could be a little bit of a buy versus build aspect to all this. But I think when it comes down to it, a simplified data pipeline will do you a lot of favors.
Yeah,
right?
Exactly. I think the allure with tools is like it lets you do more quicker, but you don't always need more. For example, if you have like a few gigabytes of data, let's say 50 or 100, you don't need infinitely scaling Snowflake data warehouse. Now you can have that, but then it has its own trade-off. You cannot test locally. It makes it difficult to spin up fixtures. So now you're sacrificing that for ease of scalability. So when people look at new tools, which they have some great features, but you always need to consider, hey, what's the trade-off? What am I giving up for this? I mean, some cases it's legitimate. You can make that trade-off, but always be aware of the trade-off. No matter what the tool is, DBT, great, but you're now stuck with SQL and writing thousands of lines of macros. So always remember every tool has a trade-off. That's my thing.
Yeah. And you mentioned local development environment.
Yeah.
I guess you assume that you're a big believer in having that available for all the developers. That's a big thing. Okay.
Yes. Because I've been in teams. If your data team is small, maybe like 1 or 2 people, you can get away with not having that. Because what small data teams typically do is they put up like a staging environment and they test it there, and then they just write the code and deploy it. But as the team grows, now there are like, let's say 8 people, they're all hitting staging environment. There will be confusion on schema names. There will be confusion on how to organize your models. There will be merge conflicts. So it's better to have like a standard software development pipeline as your team grows, because if not, it will slow down your development as well. Yeah. Yeah.
So potentially, are you advocating for a local? First of all, that makes a lot of sense to me. And would it be fair to say that you're advocating for a local development environment as well as some kind of a team environment as well? So you start with a local, and then test or perhaps do further development of the team. Okay.
Yeah. So yeah, as you might know, like with data, it's very different from web development because you can't fully trust the local development because your data size is not going to be the same as what you have in production. So having that local development space just to get your code working, making sure some test cases are covered, and then you can test it in some sort of shared environment and then deploy. That's similar to what DBT does. It creates like a separate schema for each CI test, and then test your data processing there, and then it allows you to deploy. So that way, it still lets you test in like a shared environment, but keeps it namespaced by the user. So by the PR. Mm-hmm. So yeah.
Yeah, that certainly makes a lot of sense. During one of our earlier conversations, during our prep, you talked about scaling. I think you used the term mindful scaling. Can you elaborate on that a little bit more?
Yeah. So mindful scaling is like asking. So let's say we are working on a company, and then let's say, hey, we are gonna start collecting stream data or clickstream data or log data. The immediate reaction will be, okay, let's get a warehouse. But you have to ask yourself, do we really need a warehouse? What is the incoming data size? If it's like, I don't know, 1 MB every hour, you're not going to need a data warehouse anytime soon. I'm giving a very simplistic example, but basically what I'm trying to advocate for is always make sure that if you add a new component to your system, that is absolutely necessary. So if you're adding a warehouse, now you're not just adding a warehouse, you're adding warehouse. You have to enable other systems to be able to connect to that warehouse, whether it be a dashboard system or your data pipeline system, and you need to manage it. You need to handle permissions. You need to handle schema changes. So you're putting a lot of, you're adding a lot of complexity. So again, make sure that is absolutely needed. For example, if your data is, say, I don't know, it's going to be like less than a TB a year, you might be able to get away with another Postgres server, maybe running something like Timescale DB. Now, you don't need new code to be able to connect. You don't need new ORM if you're using that to be able to work with Postgres. You can use what you have already and just change the connection parameters so it connects to a different database. It will save on a lot of like having to write new code, if that makes sense.
Yeah, it does.
Yeah, and similar things with like going for Spark. Do we really need Spark, or can you do away with the data warehouse? Spark is great. I love Spark. I use Spark at work, but for certain scales, like less than a few million rows, it's not going to make a lot of sense to be tweaking the executor memory, node memory, Spark settings to get the highest performance. Now, if you're doing streaming, maybe there's a case for Flink there, but the point I'm trying to make is don't go for the shiny thing, as you mentioned earlier.
Yeah.
Always ask like, what's the price you're paying for this?
Yeah. Certainly, yeah, it definitely ties into the complexity aspect that we were discussing a little bit ago. Yeah. So in terms of, hey, this will make your overall solution more complex. And then also, the scaling aspect of it as well in terms of having, you're introducing a whole nother tool that could complicate matters in that respect as well.
Yeah, similar with like the backend space, there's the whole argument about Kubernetes or not. Again, it depends on what scale your company is, how many teams there are. Because managing in complex infrastructure like Kubernetes is no easy task. So if you have a DevOps team, sure, maybe, but then you need to justify the reasoning, I think.
Yeah, absolutely. Hey, let's talk about testing and how it fits in all this as well. So what are your opinions on, obviously you mentioned the local development experience. Does that same apply to testing as well? Yeah, overall thoughts on testing in regards to developer ergonomics.
Yeah, so testing, I think every system should have the standard testing, like unit integration, like the standard software engineering test concepts. And in addition to that, they should also have data quality tests, because the normal kind of standard tests like unit integration, they catch errors with the code, but they do not catch error in your data processing logic. So data quality check, let me put it a better way. It catches the errors that you are not expecting it to. Because if you have, let's say you're converting, I don't know, Unix time to date, right? From epoch to Unix date function. But then if your incoming data has like 0 as epoch time and the input, now your pipeline will break. So having that data quality check is also important. So the standard data tests, unit integration must be run locally and with every CI checks. But the data quality test is a little bit complex, because if you're not running it locally and you don't have enough data, it doesn't actually help a lot, because it will easily pass. But then when you're running in production, it might fail. The typical pattern that I've seen data teams use is generate your end data, test it, and only then make it available to end user. Because once you make it available to end user, it's really hard to change, because there can be multiple downstream impacts. Your company might make a decision based on incorrect data. So data quality check is very important. I think there's been a lot of talk about it on social media, but it's been around for many years now. Because it's very different from back-end engineering, because like you can make a change and then you can revert it. But then when it comes to data, it's being used by a lot of end users. If an incorrect data is made available to them and they make a decision out of it, sometimes your companies might lose money because you're like activating the wrong audience in like advertising system, or you're I don't know, something else. You're making downstream changes that are irreversible.
Yeah, absolutely. And that obviously that's the worst case scenario. Even if you're managed to you release something, you recognize the error and fix it before anybody makes a decision on it, you still suffer some confidence issues as well.
Yeah, that's a really good point, because like people will start asking, hey, is this data correct? If you have a downstream issue, then they'll start doubting it, because then they're putting their kind of reputation on the line when they present it to others. Now they have to validate the data. So it's a crucial step.
Very tricky, and definitely one of the things that sets apart data engineering from software engineering, right? We have this extra little difficult, I guess, aspect of our jobs that we need to accommodate for, right? And that's the whole idea of data quality. Yep. Makes it interesting and also very tough sometimes.
It's kind of interesting, because like I got to see a lot of the business side of things that I wouldn't have seen if I were just in engineering, in the back-end engineering. Like, what are the terms that business people or salespeople care about? Why do they care about it? So, for example, MAU, DAU is like standard industry. I didn't know this. Like monthly active users, daily active users are like standard industry terms. I didn't know this before I came into data engineering. So, and that actually drives company valuation. So it's kind of interesting to know, but also a struggle sometimes.
Exactly the industry terminology and the things that differ from data engineering role to role. And I actually never even heard of some of the things you just mentioned. So that just goes to show you it depends on which industry you're in, right? Yeah. I think I guess I just wanted to share this about the rapid test iterations, that, that ability to, how important that is. It's not just for productivity, but I think it really helps with the overall risk of deploying code, right? This idea that if you can make it, you can release things faster, you can release things more often, and that kind of dictates that there'll be smaller changes, less affecting change to your overall code base. And I think that's a good thing for overall risk, right? If you're releasing every quarter, those changes are going to be massive. And trying to do those things, pull those off, are very difficult. So I'm always a big fan of releasing more often with smaller changes, right? Yeah,
100%. I have been in teams where we did like a bi-weekly release. It was like we start in the afternoon and then we release it, and then everyone has to test their changes. So it was not fun. It was very risky, as you mentioned.
Yeah. It's a huge event with a lot of risk associated with it. I think that's, it tends to make developers risk adverse as well. And maybe there's another topic for another time on that one. But so, as we're talking about a lot of these things, some people, including myself, I say, well, okay, this sounds like a lot of similar like DevOps points and conversations. How would you differentiate DevOps from this concept developer ergonomics?
So I think when I say developer ergonomics, it applies to like the team who's using the system. So for example, the data team is using a data pipeline repository. So it can be that the DevOps team actually built a system for the data team, or there's a platform or data platform team. Some companies do have this data platform team that built it for the data team. But when it comes to ergonomics, you do need a bit of DevOps skills in there. So if you are just purely focusing on writing pipelines and you don't know, let's say, how to set up like infrastructure or Docker containers for local development, it's going to be difficult. I would recommend anyone in software space to know a bit about the DevOps what they do and how it's managed. I mean, you don't have to know like how to, orchestrate thousands of tasks on Kubernetes, but knowing the basics of what is Kubernetes and how to use Docker and how is your code actually being deployed, what is the deploy strategy, is your system shut down and restarted, or is it more of a copying the code and refreshing it somehow? So knowing those things helps a lot with deploying your code and being confident in the changes you make. I don't see it as like a separate thing. I think it's all like connected. And when DevOps team, what's bad is when DevOps team builds their infrastructure and tells data team, hey, use this, instead of getting feedback from the data team and iteratively building out an infrastructure. That's when things get really difficult for both the data engineering team and the DevOps team. So I always think like that there should be a lot of collaboration between the DevOps team or whichever team is building the data infra and the data team who's actually going to be using it.
Gotcha. Yeah, so that definitely a lot of collaboration is what you're suggesting between the two.
Yeah, because if you like most DevOps team, they're kind of end users or customers or other engineers. So making sure that communication loop is very high throughput communication loop is important on this thing.
Yeah, low friction communication.
Yeah,
and a lot of it. Yeah. Okay, that makes sense. All right. So what are some of the, I guess, what have you seen, what have you heard about the typical obstacles for implementing developer ergonomics, some of these concepts we've been talking about? What are some of the challenges to doing that?
Yeah, I think the most common one I can think of is the not being able to test data warehouse systems locally. For example, if you're building a data pipeline, let's say for ease of example, just using Python scripts, right? You can't. It's hard to spin up a local instance of Snowflake. So if you have your warehouse is Snowflake, it's really difficult to test locally because they do have like an API-driven way to upload fixtures, but then it's really slow, and you have to like figure out what's the schema for individual user and things of that nature, and how to update the database scheme, database objects within that schema if you are making any schema changes, or database schema changes to be specific. So testing warehouses locally it's extremely difficult. I've seen a lot of companies do is use Postgres as an alternative. So Redshift, it's compatible with Postgres. So people use Postgres for local testing and then they deploy to Redshift. They do similar things with Snowflake, but if you use Postgres locally for Snowflake, there are a lot of functionality that Snowflake offers that's not in Postgres. And you are going to break. You cannot test locally.
Yeah, that's I definitely see that as fairly risky. Yeah. Even between Postgres and Redshift, I know that Redshift was built upon them, but I guess it depends on the level of testing that you're doing locally. I guess, yeah.
It's a difficult problem, and one thing that made DBT really popular, in my opinion, is the ability to test easily. So they have this infrastructure around like, hey, if you develop individually, we'll create a schema for you automatically, and then we will let you test there. So they made this really frictionless, really easy to do. I think that's one of the reasons a lot of people like that, because now you can test locally, and they also make it so that you have CI tests. So what they do is when you put up a CI, they create a separate schema, and then they write the output to that schema, and then they test your data. So you essentially have a PR specific schema, which is really nice because now you can be extremely confident that it will work in production. So that thought of ergonomics was really nice when I was using DBT. I don't know of another team that has that level of success with replicating warehouse systems locally.
No, neither do I actually. And I have seen a similar approach, just maybe more of a manual one, where having different schemas for different development branches as they were, or for specific parts of the project. So, yeah, and we're talking about database schemas, by the way. Yeah. As opposed to like a table schema or something like that. So, no, that makes Yeah, I would tend to agree with that. It is certainly one of the trickier aspects of pulling all this off, right? Having some of these nice, it's easy to say, hey, here's all the great things you get from implementing developer ergonomics. It's another thing to find a way to pull it off. But that's some good advice for the listeners.
One more thing is the external system. Sorry to interrupt. Let's
no, please.
very kind of opinionated about this. The other main thing is the external system. So if you're interacting with the SFTP server, if you're interacting with some APIs, you could mock most of them. But if you're interacting with cloud services, it's really hard to mock. So that's something to be mindful about as well. So if you're using, I don't know, let's say, an easy example is S3. You can mock it locally with something like Minio. But if you're using something more uncommon, like, I don't know, SageMaker, AWS SageMaker, it's really difficult to mock. There are some libraries, but it's finicky at best, and you have to write a lot of code just to get that working.
Yeah.
So that's the negative of having to set all this local development up.
Yeah, it's funny you mentioned that. I a fairly recent episode on AWS Glue, my guest and I, Johnny Chivers, talked about some of those problematic things of trying to, if you have code that involves an AWS service, how do you incorporate that? And having, in this case, there's a couple different ways to go about it. They make some endpoints that make it available to do some testing and development. Mm-hmm. There's also containers that you can run. That seems to be a kind of a popular approach, but none of them are easy, in my opinion, except for arguably the development endpoints are fairly straightforward, but they can also be fairly expensive as well.
Yeah, it's always a struggle. I think there are even companies around getting you started locally, like letting you run these services locally or mocking these services locally. I think OpenStack or something. That's a company that does, like, they let you mock all the AWS services locally.
Oh, wow.
And that's their entire kind of business model, which is interesting. But
wow, that's a good one. They're pulling it off with at least a fair amount of success. Yeah,
for sure. Right. Yeah, that's. I think that's why I'm like pretty opinionated about keeping complexity low as well. The more systems you add, the more difficult you make it to kind of rapidly deliver.
Yeah, absolutely. Anything else come to mind in terms of some of the challenges to implementing?
Yeah, I think another main thing I've seen is just developer mindset, because a lot of data people are used to like testing in stage or testing in production and then writing code locally. So being open to spending sometimes a significant amount of time to set this up and make sure it works can be a challenge to sell. The question is, okay, how does this help us deliver our, I don't know, Q1 deliverables? I mean, it's hard to sell that point across. So it takes a lot of convincing and takes a lot of writing PRDs and such. But that's always a struggle sometimes.
Yeah, anything that doesn't directly impact the users or the bottom line is always a tough sell. This one is no exception. But it was going to take a fairly persuasive aspect of that conversation to get this done. But I tell you what, I don't know if there's a more important thing for a development team to implement, if we're talking about to make them more productive, to increase the quality of the code base, and to deliver. Well, I guess that's inclusive of productivity, but deliver faster. This is it. So all these features and aspects of developer ergonomics are what I don't think anybody would disagree with that. Certainly, how we get it done is up for debate.
And also, it prevents the single point of failure issues where there will be typically one or two people in a data team who knows how each component link together. And if they leave, you better have some documentation, otherwise it's not going to be easy. So having these systems alleviate some of those issues. Maybe not all, but like it can give you a kind of holistic picture of what's going to happen if you just look at the code. Whereas just having to look at outdated documents or people who are not there, it's going to be rough.
Yeah, excellent points, Joseph. Yeah, too many companies rely on great people, and they don't have enough great processes. It's as simple as that. And yeah, you can have some documentation, but boy, does that documentation go stale fast. Yeah. Well, great. Hey, any other parting thoughts about developer ergonomics before we close up the episode?
I think main thing would be just think about how quickly you can deliver and how easy it would be if you can implement these kind of infrastructure level changes. So I know engineers sometimes get used to the toil of development. I always try to think about making things smoother would be my parting thought here.
Yeah, excellent advice. Well, thank you, listeners and viewers, for hanging with us on this episode. Hope you got a lot out of it. Please rate, review, and subscribe. Until the next time, thanks a lot.